Dear viewers and subscribers, welcome again to our YouTube channel Max the Service. Please subscribe and press the bell icon to receive all notifications regarding any video we are uploading on this channel. In last session, we discussed why Docker Swarm is needed, what is the purpose, and why we need it, and where we need it. Okay, we discussed all the scenario, and here again, let me rephrase. Okay, to discuss just use case of Docker Swarm. Docker Swarm is a container orchestration tool that is used to Docker containers and scale them. It's mean you within a Docker Swarm you can increase your containers as per your demand. If you have two, if there is more traffic and you feel that okay, there is a problem that we can increase more than one containers. Okay, so we can manage multiple nodes. This is your node 1 means server 1 and this is your node 2. So with these two nodes, more than 100,000 million of nodes, you can actually Docker Swarm is used at small scale. When you have more than like I say millions of containers you have to manage, then you must go for Kubernetes. But Docker Swarm can be used at small level. Okay, so we can manage multiple nodes, which is called clusters. If we have more than one nodes, then it will be become a cluster. Okay, 1 and 2. So we can deploy and maintain our containers in multiple hosts with Docker Swarm. Actually, Docker Swarm ensures that our application is always available, even if one of the node fails by creating container in another node which is available. Based on incoming traffic, we can scale. I mean, we can increase containers up, and we can, on the base of low traffic, we can down by decreasing these containers. If there are multiple containers, the incoming load will be balanced automatically by the Docker Swarm. So let me show you the architecture and explain you how Docker Swarm works. Okay guys, so this tutorial is very important because we are going to learn Docker Swarm, and Docker Swarm is our requirement to manage more than one containers running on different machine or even one machine. When we run in a cluster mode, definitely there is a mechanism of orchestration and we need Docker Swarm to overcome it. Actually, mode lets you create a cluster or one or more Docker engines called a swarm. Swarm consists of one or more nodes. Those nodes can be physical, virtual machines. Even you can go on clouds. You can use the AWS, Azure. Okay. So in this diagram, you can see first we have to understand how the structure or architecture of Docker Swarm works. Here you can see there are manager and worker. Actually, these are nodes. One we have manager node, another we have worker nodes. The duty of manager nodes is to maintain cluster states. Okay, here is the DB of states which maintain their state, and these manager nodes communicate and keep syncing with each other. These are responsibilities to scheduling the services, serving swarm mode, whatever HTTP request from CLI. What we have CLI. What is CLI? CLI actually a Docker command interface. So from here, whatever we get any API or query, but when a user execute a command, it comes to the manager node, and manager nodes responsibility to manage all of this using raft is algorithm implementation. These manager nodes actually maintain consistent internal state of the entire swarm and all services running on it. For testing processes, it is okay to run a swarm with a single manager. If the manager is a single manager swarm fails, your services continue to run, but you need to create a new cluster to cover. Okay, actually you can also, for testing purposes, you can also create single only one node manager. But remember that in this case, if this one manager, if you have one manager and it get fail, then you have to recover or recreate a new cluster, but your services will continue to work. Okay. For fault tolerance features, actually recommended approaches to use odd number of manager. I mean 3, 5, 7. Okay. Actually, a three manager swarm tolerates a maximum loss of one manager. Let's suppose if there is one manager crash down, other two will be working for the for each of backup. So these will be synced to maintain the state, to scheduling the services, everything. A five manager swarm tolerates maximum simulation of loss of two manager. If you have five and two are down, that there is no worries. Okay, so odd number is recommended. Okay, now we have another nodes. These are worker. Okay, actually they don't work like with the Raft algorithm. Okay, actually when we execute our application, we run image as a container. Here our application start running. This manager is to just manage your services, scheduling task, everything. But when you start a worker node, then definitely you have to assign an image, and here in this worker node, your image as a container will be running. Okay, important thing is you cannot have worker node without manager node. Okay, if there is a manager node, then you can have worker node. Without manager node, you cannot have worker node. Another important thing, you can promote this worker node to manager node, and you can depromote this manager node to worker node. This is important thing we have to know. Okay, let's suppose we have less manager nodes and we have many worker nodes, then we can promote any worker node as a manager node, but the responsibility and management will be changed accordingly. Okay, another important thing, uh, if you don't want to allow this manager node to assign any task, to schedule any service, then you can set this manager node into a drain mode. Because when it will be drain mode, it will not managing any services, it will not assign any task to service, because it create a service object and it also assign a task to that object, and that this worker node also assign get an IP address where that service get running. So I will show you in another diagram in detail how this work. Okay, guys, next is how service work. Definitely, when you create a service, there must be an image already built, and you want to just run that image as a container, and that will be a service. Okay, and when you create a service, you specify which container image to use, and which commands to execute inside the running container as well. You also define option for the service include like port, overlay network, I mean network type, CPU and memory limits, rolling update policy, number of replicas. Here you have number of replicas 3. Whenever you create a service, you can define, okay, I have number of replicas services, because whenever your one node is down, other will be up and running, and this swarm manager will work as a load balancer. Okay, guys, it is very important to understand when we create a service, and a Docker swarm manager receives request from CLI or any API call to create service. Okay, and how the service create request accept. When I create service, how the swarm manager accept the request, schedule task, and to worker node. Okay, so this is the flow, very simple. Whenever Docker create service, run this command, accept command, and create a service object. Okay, this is API for this. Now object, service object is created. After that, reconciliation loop that create task for service object. There another task is created for that particular service you created. Okay, then definitely you must run this service as a container on some worker node. Okay, in last diagram we see that there one worker node. Every worker node is a separate system and must have IP. You might have a virtual machine, you might have uh, uh, a whole system, but that must be assigned an IP. Whenever an task is attached to that service object, then allocator assign IP address to the task. Okay, this is a task to be run on 1.9.3.5, 1.4.3.2. So this is the IP. Let's suppose I'm just putting an example. Let's suppose we have IP of worker 192, sorry, 192 dot 168 dot 0 dot 1. Let's suppose this worker, uh, this node, worker node have IP 192.168.0.1. The allocator will assign this task to this IP. Okay, please take this service and run on the this worker node. Then it release the task to the nodes after assigning IP. If there is a worker node pending in pending state or not available, definitely you must have a Docker Swarm have a load balancer. It will go for another node. Okay. So after that, once IP assign, it is assigned task to that node. Then it will instruct worker to run a task. It will schedule if already it is running some task, then definitely it will go and run another task with another node. Okay, then what worker node do? It connects to dispatcher to check for assigned task. It responsibility to check with scheduler. Okay, is there any task I can run? It will be connect with the scheduler, and then it execute the task assigned to worker node. So this is very simple to understand how service is created, how the task is assigned to the service, and etc. Guys, there are two types of deployment services. You can deploy services in two types, like one is replicated, another is global. Here you can see there are three service replicated, one, two, and three. And this global service is not replicated. Actually, for replicated service, you specify number of replicated server. Let's suppose you have a one service, you are creating a service, and you can specify number of three, five, whatever number you want to mention, and all those services will be serving the same content, same purpose. Okay, you decide to deploy HTTP service with three replicas, each service same content. A global service, okay, here black dot is a global service. Actually, service that run one task on every node. You can create global service on every node, only one global service, and it will be serving one content, one purpose. Okay, there is no pre-specified number of tasks for global service. Each time you add a node to the swarm, whenever you create a worker node in the swarm, okay, the orchestrator create a task and the scheduler assign the task to the new node. Okay, this manager node will create a scheduler task and this will be assigned to the new node. Okay, actually good candidate for global service are like monitoring agents. You want to run a global service just for monitoring agents, there is a antivirus to be running every day, or other type of container that you want to run on every node in the swarm. Okay, so in this session we have covered architecture components and I have explained you in detail. I hope you have enjoyed, and here are the key points which we have to remember what we have learned. Just I am rephrasing. And then in next session we will be learning how to manage swarm security with public key infrastructure and we will also discussing swarm task states, and we will try to cover join nodes to a swarm, how we can join node to the swarm. Okay, so stay tuned and keep watching. I will share you. Let's meet in next video. Thanks. Okay, please subscribe my channel if you are not subscribed yet, and also do like, share in your circle these videos, and also provide your valuable comments. And I hope you will be liking and sharing, so that I will be continuing with rest of the technologies and tools sharing with you. Thanks.